industrial activity, agricultural practices, maybe even those cows that guy was complaining about. Okay? But we are adding greenhouse gases to the air, and it's not quite correlated to temperature. Take a look here. Here, CO2 is rising, and temperature is still falling. A little remnant of the last little ice age that we had. And finally here we have some correlation between temperature and CO2, except not quite here. This graphic is incorrect. And I'm a little complain about it because this happens to be in the National Climate Assessment. And they don't quite show the fact that for the last 20 years, we really haven't had atmospheric temperature change. We had a CO2 going up. I'm going to get back to that in a minute. Here's a graphic I was telling you about. This is for the last 2,000 years, okay? CO2 is the green line, flat as a pancake. In medieval warm period, temperature skyrockets for a while, and in a couple of phases. Then we had a little ice age where it plunges. CO2 has no influence, has had very little influence over the temperature in this 2,000-year period. Finally, we happen to be putting CO2 in the air at the same time that temperatures are rising again. But this is the correlation and not causation that you need to understand. Just because things happen at the same time does not mean that one drives the other. At the end of this presentation, I'll show you a graphic that really shows that. But right now, you understand that we only have 4.5% correlation between temperature and by the way, under this black arrow, that's the last graphic I showed you before. Right? That's just that little subset of the last 130 years. So, here we have a 7,500-year spike in here, and then we're leveling off in sea level. Now we're back on sea level. This is the Mauna Loa carbon dioxide curve. Again, CO2. It looks like a sawtooth. And why is it a sawtooth? Because this is northern hemisphere data. There's a similar graphic for the southern hemisphere too, which I need to get one of my NASA TRCS colleagues, George Stegelmeyer, to give me, because he used it down in Texas a couple of weeks ago, and I liked it. But I don't have it yet. The reason we have a spike in the spring is that here the plants come out, the leaves come on the trees, they suck in carbon dioxide. In October, the leaves fall, and then carbon dioxide rises again for the next spring. So you see this sawtooth, but you notice there are a couple of places here where it actually drops. CO2 actually dropped. Now what did that? What did we do in the 1960s that would make CO2 drop? Well, the fact is we didn't do anything. It happened to be a volcano in Indonesia that did that, blanketed the earth with soot and things like that. The soot created particles for water vapor to condense on, so you had cloud cover over the Pacific. And that's why CO2 actually dropped, because the oceans didn't warm. The oceans are the great releaser of CO2, not plants. Here it is, it's Agung in Indonesia, and here's the effect. For 3 years, carbon dioxide actually dropped. Pretty powerful volcano. I'm going to use this graphic later on to show you the differences. The yearly differences in CO2 are very small, by the way. CO2 is rising steadily, but between one year and another, there's not a lot of difference. But there is a difference, and the fact is we are contributing to that difference. This one's a little bit busy. I'm going to try to walk you through this chart. This came from the IPCC and our own Department of Energy. And it shows you what's going on in the world. The source for CO2, 97% is natural. 97%. Human-made is 3%. The total is 100. But then we have reabsorption. The plants and the oceans reabsorb some of that. So the net increase each year is about 1.5%. Not very little. If you look at it in metric tons, million metric tons, you're talking about 77 billion metric tons are natural to come out of the oceans because the oceans are warming. Molecular motion increases, they kick out the heavier CO2 molecules. The humans create 23 billion, but they reabsorb, so what's left is about 11. That's the annual increase per year. Methane and other, and these are those calories they were talking about, are almost inconsequential. Even though methane is 23 times as heat trapping as CO2, it's still 1.8%, 1.8 parts per million in the atmosphere. And it really does not contribute very much from a greenhouse gas standpoint. Here's a different way of looking at it. Here's your annual increase between these 2 years. You notice where this spike ends and this one begins. It's 11 billion metric tons. The total range is 793. It's still very big. So here you have the addition, the reabsorption, and the net increase. And the net increase is this thin line right here. Here's an enlargement of that same graphic. If we do everything that the Paris conference hopes is going to happen, we are not going to be able to even fit in the blue line on top of the 11 billion metric tons. It's such a small reduction. And that reduction is if everybody does, quote, everything right in the world. It is almost inconsequential. Here's a graphic from a tectonically inert place. Remember I said about ice being on the continents, Norway rising, because the ice is gone from Norway, and it rises. And people in Norway say, hey, the sea level is dropping at 7 millimeters a year. It's not, they're still rising, because of the weight of the glaciers that was removed. The ocean next to it is getting a little bit deeper. Holland and Belgium are on the other side. You can imagine a seesaw. It's like, here's my elbow, here's Norway, going up like this. Holland and Belgium going down. In between both is a place called Wysmuller, Germany. And Wysmuller, Germany has a rock-steady sea level rise. There's obviously variation from year to year. But it's about 1.4 millimeters a year, and that is steady. And the reason I'm showing you this particular graphic, even though Wysmuller is tectonically inert, we've had a massive 38% increase in CO2 over the exact time period of this graphic. Do you see any acceleration at all in the sea level rise in a tectonically inert part of the world? And there's about 30 or 40 of these in the world, and they all look the same. There is no evidence at all that CO2 influences this sea level rise. The tide gauges don't lie. The satellites, by the way, do. Why do they lie? Lying is the wrong word. They also are showing a linear increase. But they're showing a, quote, adjusted model linear increase of about 3 millimeters a year, 3.4 currently. But they're not validated. At NASA, we used to validate our models. We would not do anything that put a human life in danger unless we validated the model that was creating the design that we were trying to do. They didn't do that with the satellites. What they needed to do is look at the satellite data and compare it to places like this. And see, it had to be identical. They're both linear. They're both going the same place. This is not moving because it is tectonically inert, and yet you do have a rise because of thermal expansion. And a couple of other factors. Extraction of groundwater for agricultural use and things like that. There are other things influencing this, not just thermal expansion. I happen to think thermal expansion is the greatest of them, but it is no signal at all of any acceleration in sea level rise because of the massive increase in CO2. Skip this. Now, the question I posed to Paris, can their proposals have any impact on sea level rise? And the fact is, we don't have an instrument that could detect it. It doesn't exist yet. You guys want to invent one? Great. It'll be useful for the world. But it is not detectable at all, even though we've had a huge increase over the 135 years. So here's a list of the things that are being proposed in Paris. This is by Bjorn Lomborg, who's also a Danish scientist. And he puts down what the US will do, what Europe will do. If the grand total is that we would get a 0.064 Fahrenheit increase in temperature. if we decrease in temperature, if all these come true. Now, what I noticed in the top here, he doesn't tell you how much this is going to cost. There is money needed to do this, billions of dollars, to accomplish this minimal diminution of temperature. And that money is wasted because it doesn't accomplish anything. And the technology that's being withheld from the third world also doesn't get spent because they're wasting on this. There's a better way to do it. This way. The best hope for COP21, and this is what they expect, and this is the best hope. And by the way, this graphic is wrong. Why is this graphic wrong? Because it doesn't show that we've had no temperature increase. This should be flat. What they've done is they've taken their model, worked it backwards, and it doesn't work backwards, and it doesn't work forward. All right? It's called hindcasting, and you failed. All right? This is what the real temperature, this is atmospheric temperature. And this is measured by satellites out of the University of Alabama. We've had no global warming in the atmosphere, not the oceans, by the way. The oceans are still increasing in heat, with the exception of the Southern Ocean, but that's a different story. Those 7 oceans are increasing in heat. The world is getting warmer, so global warming as a factor is in fact real, but the atmosphere within which we live has shown really no increase at all. And that's not in the high-cast graphic I showed you before. So what's really behind it? First of all, how many of you remember hearing about Willie Soon? Dr. Soon works for, okay, good, we got one person who reads the newspaper. Thank you. Dr. Soon works for the Harvard Smithsonian astrophysicist. He's a recognized worldwide expert on the sun. About 6 months ago, the New York Times, the Boston Globe, to its discredit, Washington Post, all came out with articles within a week of each other talking about Willie Soon taking money from oil companies to do research. The fact is he does brilliant research. He solicited oil companies and universities